Next project that needs more immediate attention is the heater, the hot water heater on the fifth wheel trailer. We've got Columbus Day weekend just about upon us, and the last 2 times we went camping we had to run the heater off of gas, which this is a dual fuel heater, meaning it runs off of gas, but if you have electricity hooked up 120 volt, it will run off of 120. But the way that it does that is kind of screwy. The way that it works is you've got inside, this is what's called, I think it's called the DSI, Direct Source Ignition Heater, if I'm not mistaken, or something like that. Anyways, the way it works is you've got a switch inside the trailer for the heater on gas, and when you turn the switch on, a little LED light comes on, and the igniter will start sparking, and the solenoid valve will open, gas will start flowing, and once the pilot is lit, the LED will go out to let you know that the heater lit. You'll also hear that kind of low muffled jet engine sound of the heater running. It's also kind of a dead giveaway that it's running. That's for on gas, but when you're hooked up in a park on power, 120 volt, you can run this on AC, 110 AC. But in order to run it on 110 AC, what you have to do is you shut the switch off for the gas, and you come outside the trailer. You know, believe it or not, they didn't put a switch inside the trailer for this. Outside the trailer, you come to the outside here, you open this, and you go under here where the switch is hidden, and you'll see there's a rocker switch right here. Now, not only is the switch hidden, so you can forget it a lot, there's no light to indicate that it's on. And the worst thing is, if you look, when they installed this switch, you will notice that the off is on the top and the on is on the bottom. So, that's dumb. Alright, so here's what ends up invariably happening. You leave the park and you forget this switch in the on position. The water level in the heater drops down, and the heating element is exposed. It's not submerged in water, which is what they call a dry fire situation. The heating element will overheat and burn itself out rapidly. It doesn't take very long at all for this to happen. So it's a common occurrence for this heating element to burn out, and I did it this season, and I'll probably won't be the last time I'll do it. Now, you can go to a RV dealer and have them repair it for you, and then you're going to pay the labor charges, and you're probably going to pay a premium for the heating element also. So the dirty little secret about this heating element is this is not a special type of element that you have to buy from an RV dealer. This is something that many hardware stores will carry, and even Home Depot or Lowe's sometimes will carry them. There's also a special wrench that they use to take this out, and I'll get to that in a minute. So the first thing I'm going to do is, I believe that the heating element is actually under this cover right here, so I'm going to remove these 3 little screws. Okay, so there's the back of the heating element, and it screws into the tank right there. And you've got 2 wires going to it, and so the first thing I'm going to do before I go any further is I'm going to take a continuity check between these 2 screws with my ohm meter. Okay, so I've got my multimeter and I've got it set to resistance, and now I hold the probes in the meter right, one on each screw head, and lo and behold, you will see 10.4 ohms. You know what that means, guys? That means that this heating element is good. So I've got something else wrong here. Okay, now I've switched my meter to AC volts. So I'm going to go across the same 2 screws and I'm going to turn the switch on. 0 volts. Couldn't show you because I can't hold the pins on and flip the switch and all that at the same time. But there's 0 volts. So I've got to find out why I'm not getting any voltage. Let's go check the circuit breakers. So here's the main breaker panel for all the power in the trailer. All of these fuses over here are for our 12 volt devices. And we know the heater is an AC device, at least the part of the heater that we're dealing with. So it's got to be one of these breakers. And the dealer or the manufacturer labeled them. We've got a main, which we know is on, the air conditioning, microwave, WH for water heater, and then I'm not sure what that is, and the GFI, that's probably the outdoor outlets. So this is the water heater breaker, and it is not tripped. Another suspect could be the actual, I believe there's actually a thermal circuit breaker behind here, where basically when the temperature goes too high, it will pop and shut power off. Now, it says push to reset. I did try and push these when we were at the park, and nothing seemed to happen. But now I'm going to pull this little rubber thing out and see if I can see. Because I think I pulled it out to look behind it. Yeah, there it is right there. And if it was tripped, normally what would happen is when you would push this little thing, you'd feel a little click as it resets, and I don't feel that at all. Yeah, they really kind of make it a pain to get to a lot of these screws. It was very difficult to get this screw out with this in the way, and then I found out this isn't going to come off unless I take this off or this off. And since I had trouble getting those screws out with this in the way, I'm just going to take this heating unit out. So what I got to do is shut off the gas supply to the trailer, disconnect the gas line right here, take out a couple of screws that hold this assembly in place, and I also undid this nut that was right on this stud right here. Alright, so now what I did was I removed the solenoid, the regulator, the solenoid unit, the burner tube here, or whatever you want to call it. It's pretty easy. Again, you know, there's a nut on here that you have to loosen, and then there's a few screws that actually attach that bracket to the back there. But before you can do that, you want to make sure your gas is shut off at the tanks, both tanks, and loosen up this nut a little bit, crack it, bleed off any gas that's in the line, and then once you get this whole unit out, oh, and also you got to disconnect these two wires right here from the solenoids. Doesn't matter which polarity they are, so it's not, if you put those backwards, I don't think it's going to make a difference. But they are color coded, so just to be on the safe side. Well, yeah, it wouldn't make a difference because they're common to each other, but since they are color coded, when we put them back on, we'll put them back on blue to blue and pink to pink. Anyways, once I have that off, now you can see if I needed to change my element, it's a lot easier to change it now. But what I'm going after is I'm going after these devices up here, and what we've got is this plate, which is held on by this nut right here, and this plate, which is held on by a nut right here. These are special little units, and what they have is they actually have a thermostat down here and then a high limit up here. And then you've got another one on this side. The reason why there are two on this heater is because this heater is designed to work on gas with the 12 volt running the electrical, or on 120 volt. So this side is working fine because it works fine on gas. This is the side that's got a problem, and the way you test this is pretty simple. And oh, this little red thing right here, this is what's right behind that little rubber plunger on the cover, where it says push to reset. So if your high limit on your 12 volt pops, you just press this button to reset it, and if the one on your 120 volt pops, you press this button. Problem is, it's not popped, but it's not passing any voltage. So what you do is you take your ohm meter, and again, this is power's off. I'm looking at electrical resistance, and you want to go from where one wire attaches to the other, and you'll see I'm getting no continuity. Now I'll go on to the good one, and you'll see I'm getting continuity. So this one is bad. I can actually further isolate it. The bottom one's a thermostat. The thermostat one is good. The top one, the high limit one, is the bad one. And I already looked real closely at it, and I can actually see that it's actually broken or melted off right there. You can see it? See it right there? It's completely cooked. So I've got to remove this unit and replace it. Oh, one other important step that I did that I forgot to mention prior to doing the continuity checks on the thermostats here, and prior to taking it out, is to make sure that the power is off. So I've got my breaker off inside there at that main bus panel, but if you're not sure whether or not the breakers are labeled correctly, or if you're just not sure which breaker it is, the best bet is to just unplug the whole unit. And then also keep in mind that even if you unplug the whole unit, there's still a possibility of there being 12 volts here. But as you can see, I'm not too worried about 12 volts. That's not going to give me an electric shock, but you do want to be wary of it because you don't want to touch a screwdriver or something to this that could short that out, blow your fuse. Alright, so there we go, and stamped right on it there's a part number 312155, which I think is the correct part number for this. But if you don't have the correct part number for it, then what you want to do is you want to see if you can find a parts breakdown for it online, and then if you have to order one from a dealer, you want to get your model and serial number information, which is on a label inside here. So that's it for now until I get the new one in.